Hi everyone, this example is a little bit of a precursor to solving trig equations, which we won't do for a little bit still, but it's one of our big uses for symmetry. So just to kind of give you the beginnings of this gives you one piece of information for free that you would have to get for yourself if we were solving trig equations, but we can still get the idea of one of the ways symmetry is really important later. So if I tell you that cosine t, I don't know why my circles always get these divots, is equal to negative 0.8. I'm saying that the x-coordinate on the unit circle of your points is negative 0.8, so you're pretty far out. There's a point in quadrant 2 and a point in quadrant 3, so this is x-coordinates of negative 0.8. The part you'll have to be able to do yourself, it's not terribly hard, we're just not quite ready to talk about it yet, is how do we get a t value? If we know the x-coordinate, how do we work backwards and get a t? And our calculator will do that for us, but for now that's not even what I'm looking for. I'm giving you one of them. I'm telling you that 3.8 is one of the t values that will land at one of these points. If t is 3.8, it has to be this bottom point because we know that halfway around is 3.14. So this is less than 3.14, and this is just a little more, so that seems about right. So this is t is approximately 3.8. And our job for this problem is to say, well, if we've got one of the t values, how do we get the other? And this is exactly what will happen. That's not the one our calculator would have given us, but this is exactly what will happen when we solve trig equations. We'll have a way to get our calculator to give us one answer, but that will only land us at one of the points. So not only are there infinitely many other arc lengths that land at the same point, but I have to figure out what arc length would land at this point. So it would be really nice to know well, there's a couple of choices. How far this is, that would be nice, or in the opposite direction would be nice. And actually, the opposite direction looks easier to figure out, but it doesn't quite fit the requirements of this problem. We're supposed to come up with an arc length between 0 and 2 pi. And if we go this direction, what we're getting is a negative 3.8, which is fantastic because that's fairly, I hope, fairly easy to spot. You just flip upside down and you're going negative 3.8. If we want it to be between 0 and 2 pi, what we'd rather think, okay, so that's slightly negative. It's a little smaller than negative pi. We need to add 2 pi to it. So to get this length right here, you have to do a 2 pi minus 3.8. So all the way around, and then we cancel out the 3.8 of it by going backwards. And this orange that we're left with is 2 pi minus 3.8. And I'm actually fine if you just leave it like that. The quizzes and exams we're working on right now are no calculator, so I'm not expecting you to try and change that to 6.28 and then do the arithmetic. Just seeing the symmetry and saying 2 pi minus 3.8 is wonderful. Okay, that's it for that one. Just a quick one. Thanks for watching.